So this is going to be a quick video to review the different forms of linear equations, as well as writing equations of parallel and perpendicular lines. I have included this foldable template in the OMS for you today. What you are supposed to do is you are going to fold it in half hot dog style. And on the front is each name for the different types of formulas we use. We use slope intercept. We write equations in point slope. We write equations in standard form, and we write equations of parallel and perpendicular lines. And notice our parallel lines are lines that go in the same direction but never intersect. And our perpendicular lines are lines that intersect at a 90-degree angle. Now, when the lady printed this for me at this Office Depot, she printed it backwards, so the labels were on the bottom of my foldable. They should be on this side and be on the top. And what you're going to do is you're going to cut the dotted lines so that each flap is going to fold up to view each different formula. So I'm going to pause the recording for a second, and I'm going to do that on the other side, and then we're going to go through these together. Okay, so I have cut the flaps on this side, and I'm just going to write the name of each formula as they should be. And again, if you don't have a printer, this is a great way to do it. Just take any piece of paper and fold it in half hot dog style, cut it in 4 equal slats on just one side. And we're going to start with our first flap. And the first formula, which is our most popular, is slope intercept form. Slope intercept form is our most popular formula. So what is the formula? The first thing we're going to do is we're going to write this formula here, and it is y equals mx plus b. Y equals mx plus b is our formula. So what are the characteristics of this formula? Well, the big things to look at are m and b, okay? With m being our slope, which we know is our rise divided by our run, or change in y divided by our change in x. You were actually supposed to watch a video about slope, so that should make a lot more sense. And then we have our b, which is our y-intercept. Okay, so we have our y-intercept here, and that is where we cross the y-axis. Okay, so those are characteristics of slope-intercept form. Everybody should know how to write an equation in slope-intercept form. Moving forward into what we're about to do is going to be incredibly difficult if you are not very, very, very comfortable with this formula. Okay, so make sure everyone can see this. Maybe I need to get a little closer. All right, hold on. Try to write in pencil so it doesn't bleed through. There we go. That's a little bit better to read. All right, so when is it best to use this formula? When is it best to use this formula? When you are given a slope and a y-intercept, or when you are given a graph. Okay, so typically it's best to use this when you're given a slope. So given m and b, basically you just plug it in. Or when you're given a graph. It's very easy to use when you're given a graph because you can just look and find both m and b. Okay, so it's best to use when given slope m and a y-intercept b, or when you're given a graph. And we're going to do 2 examples of this very quickly. Make sure that you understand it and it makes sense. Okay. So our first example is if I give you m equals -2 and b equals 5, what you're going to do is we're just going to say, all right, well, that's pretty easy. If my equation is y equals mx plus b, I'm going to plug in for m and I'm going to plug in for b. So I get y equals -2x plus 5. That's all you have to do. If you're given a graph, it's pretty easy to do this too. What you need to find is the slope, and you need to find a y-intercept to do this. Y-intercept is always what I start with. In this case, the y-intercept is 2. It crosses the y-axis at 2. The slope, I always use the y-intercept for a point, and then I look and say, okay, where is there another good point? Well, there's another good point right here. Goes perfectly through a coordinate. That's a negative negative slope by going down 1 and right 2. So my slope is negative 1/2. So my equation, when I plug it into y equals mx plus b, is y equals negative 1/2 x plus 2. So this is my equation. You also need to be able to solve for y. So I'm going to put a little star down here and I'm going to put solve for y. So if I give you any of these other equations, you need to be able to solve for y and put something into slope intercept form. And we're going to talk about that more as we keep going through this foldable. All right, the next formula that you use a lot and you'll see in math, especially in algebra, is your, which one comes next? Point slope formula. Point slope formula. Okay, so the point slope formula is next. And as you can imagine, point slope formula is going to give us some other important information. What is the point slope formula? Well, it is y minus y1 equals m times x minus x1. Okay, characteristics of this formula you need to know is given the slope. You are given the slope when you use this, which is your rise divided by your run. Okay, also gives you x1, y1. X1, y point is a specific point on the line. So it's a specific point on the line you're writing the equation for. Okay, so when is it best to use point slope form? Obviously, when you are given a slope and a point, and when you're given 2 points. All right, so given a slope and a point and given 2 points is when it's best to use point slope form. And that's because you're going to be able to get into point slope form rather easy from these two. All right, you also need to be able to go from point slope form to slope intercept. A lot of times what we'll do is if we're given this information, we'll start here. And then once we get this equation written, we'll solve for y and we'll end up back here at slope intercept form. So let's look at these two examples. Our first example, we give you the slope of negative 1/3 and a 0.6 negative 2. So this is your slope m, and then this will be x1, y1. And you just plug it in. So y minus y1, so negative 2. And notice it's minus negative 2. If y1 was a negative 2, that's what we plug in. Equals negative 1/3 is my m times x minus x1, which is 6. This is the slope or point slope form equation. The only thing we would do is we know that 2 minus signs becomes a positive. So y plus 2 equals negative 1/3 times x minus 6. Once you do that, it is pretty easy to solve this and put it in slope intercept form. We need to always make sure we know, okay, if I need it to, could I isolate y and put it back in slope intercept form or into slope intercept? All right, number two, we're going to find the slope first. We can't do anything here because we need its point slope form. We need a slope to be able to do this. So when I go ahead and try this, I need to do x1, y1, x2, y2. We're going to use the slope formula, which is y2 minus y1 divided by x2 minus x1. This is another one of those formulas that you must know. Okay, so I have 5 minus negative 3 divided by 1 minus 4. We do keep, change. So I get 8 divided by, and then 1 minus 4 is negative 3. So my slope is negative 8/3. And you have the option of choosing whichever point you want. It doesn't matter. The interesting thing is that you could write in two different point slope form equations, one with this point and one with this point, and either one, when you solve it for y and put it in slope intercept form, it will end up being the same equation. So I always just use the first one because I already have that labeled x1, y1. So I will just do y minus negative 3 equals negative 8/3 times x minus 4. That's going to become a plus. So y plus 3 equals negative 8/3 times x minus 4. And that's my point slope form. Okay, so we have slope intercept, point slope, and then the last one we're going to have is standard form. Standard form is another form that we're going to be using a good bit in the unit to come with systems of equations. So standard form doesn't straight up give us necessarily like a slope and a point or slope and a y-intercept, but standard form is a way that allows us to work a lot with equations in a way we want to, where we have the x and the y on the same side. So what do we know about standard form? What is standard form? Well, it is the formula ax plus by equals c. Okay, and there's a couple of characteristics about this that's important to remember. All right, a is not supposed to be a fraction or negative. So a cannot be a fraction or a negative number. So it cannot be a fraction or a negative number. All right. B and C are, they can be negative, but these also cannot be a fraction for both of these. So we don't ever have fractions in the standard form. They do, we have to get rid of them. Okay, so when is it best to use standard form? It's best to use standard form or change to standard form, or I shouldn't say best to use. It's easiest to switch to standard form when you're given an equation already in slope intercept or point slope. In point slope or slope intercept form. So it's easy because otherwise, what you have to do is like, if I gave you 2 points and you're choosing, if I gave you 2 points, it's a lot easier to go right into point slope form. So if I give you 2 points here, it's a lot easier just to go right here and then have to go here. So this one's easiest when it's already in one of these other two forms. So what I have here is I have an equation in point slope form and I have an equation in slope intercept form. We're going to put these in standard form. So the first one is y minus 2 equals 2/3 or times equals 2/3 times x plus 6. So when I'm doing this, what I am going to do is first thing is I'm going to distribute, okay? So I'm going to distribute the 2/3. So I have y minus 2 equals 2/3 x plus, and then 2/3 of 6 is 4. Okay, so 2/3 of 6 is 4 because 2 times 6 is 12. 12 divided by 3 is 4. And then I'm going to add 2 to each side. So I get y equals 2/3 x plus 6. So right here, I've just put it into slope intercept form. So I've gone from point slope to slope intercept, but I'm not done. I need it in standard form. And we know that standard form, ax plus by is on the same side. So what I'm going to do, and I'm running out of room, is I'm going to subtract 2/3 x from each side. Those will cancel, and I'm left with negative 2/3 x plus y equals 6. Now, here's the problem. There is a fraction and a, the leading coefficient is negative. So what I'm going to have to do is I'm going to have to multiply by something to clear that fraction and clear that negative. And the number I'm going to choose is -3. And here's why. A negative and a negative is a positive. A negative times a negative is a positive. 3 in the numerator and 3 in the denominator are going to cancel. And this is just going to leave me a positive 2x. But here's the catch. If I do it to this term, I have to do it to all the terms. So everything's going to be multiplied by -3. So I get positive 2x, but then I get a minus 3y equals -18. And this is the equation in standard form. So I went from point slope, I gave it to you in point slope. You took a little pit stop over here, we're in slope intercept. And now you finally got down here to standard form. All right, looking at example 2, I'm going to write it down here so I have a little more space. Y equals negative 4x plus 2. Um, I don't have to do any multiply or distributing. I'm just going to move this negative 4x to the other side by adding 4x. So I add 4x to each side, and it works out pretty nicely. I get 4x plus y equals 2. So far, so good. That's went straight from slope intercept into standard form. And this one, I don't have to worry about anything else. It's good to go. So when we get into talking about elimination, we're going to use standard form a lot. So it's very, very important that you guys are familiar with all three of these forms because we're going to use them all the time. The last thing we're going to talk about is parallel and perpendicular lines, okay? So this is the equations for parallel and perpendicular lines. I gotta check and see. I always misspelled parallel. I did it right. Awesome. All right. So, what are the rules for parallel and perpendicular lines? This is something we're going to use a lot when we do systems. Okay. So, the first thing you have to know about parallel lines is that they have the same slope. If you did not know that, you need to know that now and you need to memorize this. They have the same slope and they have different y intercepts. Okay, so parallel lines have the same slope and different y-intercepts, okay? And 9 times out of 10, we're going to ask you to write an equation in slope-intercept form for a parallel line, okay? So, and we're going to practice this in class too, but this is important to remember. This key right here is that they have the same slope. That's the big thing to remember. So, I want you to write a line, equation of a line that's parallel to y equals 5/8 x minus 3 and passes through the point 16, negative 1. So here's what that means. It's parallel to this line and it goes through this point. So right now, if we know it goes through this point, we know that this is basically an x1, y1. This is a point on that line. All right. So I have a point. I want to write an equation. So if I have a point, probably going to be using point slope form. Well, we know point slope form is y minus y1 equals m times x minus x1. So I have the x1, y1. I need the slope. Well, I actually don't have to do any work to get the slope. They gave it to me. They just gave it to me in a roundabout way. They said that this line, we're writing an equation of a line parallel to this one. Well, if they're parallel, they have the same slope. The slope of this line is 5/8. So that means the slope of my line is also going to be 5/8 because these two lines are parallel. So what I'm going to do now is I have my slope and I have my point. I'm going to plug into point slope. So I have y minus negative 1, which we know is going to become plus 1, equals 5/8 times x minus 16 because x1 was 16. I have it in point slope, but I also really always want to go to slope intercept form. So I'm going to go ahead and distribute this. So I get y plus 1 equals 5/8 x. And 5/8 minus 6 or times negative 16 is negative 10. And then it's not in slope intercept form, so I subtract the 1 from each side. So I get y equals 5/8 x minus 11. Here's my equation in slope intercept form. I have a slope, I have a y-intercept, and that would be very, very easy to graph. So the thing with parallel lines is to know that they have the same slope. So if parallel lines have the same slope, what's going to be the case with perpendicular lines? Well, the characteristics of two lines that are perpendicular is they have slopes that are negative reciprocals. And they also have different y-intercepts. So I'm saying negative reciprocals. What does that mean? Well, you have to understand what a reciprocal is, all right? A reciprocal is like the a negative reciprocal is like the negative opposite. For example, if I had negative 5/8, The negative reciprocal of that is positive 8/5. It's basically flipping a fraction and changing the sign. So if it's negative, that means it becomes positive. If it's positive, it becomes negative. So we're going to write an equation of a line perpendicular to y equals negative 1/3 x and passes through 2, -2. Okay, so again, passes through 2, -2, so that's our x1, y1. Now we have a point, so we're going to start in point slope form, but we still need a slope. We still need a slope. So what is my slope going to be? Well, the slope of this line is negative 1/3. So the negative reciprocal of that is going to be positive, and it's going to be positive 3/1. Or we know that simplifies to just 3. So my slope is 3 because that's the negative reciprocal of negative 1/3. So now we're going to plug that into my point slope equation. So y minus -2, which we know becomes plus 2, equals 3 times x minus 2. That's the endpoint slope. And now we're going to put it in slope intercept by distributing that 3. So I have 3x minus 6 equals y plus 2. I'm going to subtract 2 from each side. I get y equals 3x minus 8. There's my equation in slope intercept form. So if I graph this line and I graph this line, they will be perpendicular to each other, intersecting and making a 90-degree angle. Okay? So that's how we're going to fill out this foldable. All right, and I'm going to do 1 or 2 more examples with you of parallel and perpendicular lines just to make sure they make sense. I am sorry if this one was a little bit hard to read. I really want to show you in the foldable. If there's anything you couldn't clearly see, you can ask, and I can also, if you need me to, put up a completed version of this. So I'm going to pause this real quick and put up the whiteboard, and we're going to do 2 more examples. And I know this is a long video, but I want to teach this lesson in this video. All right, so we're gonna do an example of equations of parallel and perpendicular lines. And the big thing to remember are these rules about the same slope and the slope that's the negative reciprocal. So what we're gonna do is we're gonna write the equation of a line that is parallel to y equals, let's do negative 2x plus 4, and passes through the point 1, -3. So we have our point, which is our x1, y1, and we just need our slope, okay? And our slope, they've actually given it to us. It's going to be the same as this slope because they are parallel. So if this line had a slope of -2, my parallel line will also have a slope of -2. So we have a slope and a point. So we're going to go into point slope form to start. And we're going to say, all right, y minus -3 equals -2 times x minus 1. And we know that becomes a plus. And we're going to distribute. So y plus 3 equals -2x plus 2. And then we're going to subtract 3 from each side. And we're going to get y equals -2x minus 1. So this is the equation of a line in slope intercept form that is parallel to this line. Notice they each have the same slope and they have different y-intercepts. So these 2 lines are parallel on their graph and they would never intersect. And that's important to remember for what we're getting into pretty soon. All right, the next one we're going to do is we're going to draw or write the equation of a line that is perpendicular to y equals 4/5 x plus 5 and passes through the point. I got to think about this one. 8, 3. Okay, so we have our point, we have our x1, y1. And so we can go into point slope form, but the problem is we need our slope. So, well, what is my slope? Well, they've given me some important information. They said it's perpendicular to this line. This line has a slope of 4/5. So slopes of perpendicular lines are negative reciprocals. So this line had the first line had a positive slope. So my new line is going to have a negative slope. My first line had a slope of 4/5. So my new line's going to have a slope of 5/4. That is the negative reciprocal. Okay, I flipped it and I changed the sign. So I have m, I have x1, I have y1. Let's plug everything in. Y minus 3 equals negative 5/4 times x minus 8. All right, there's my point slope form, but I want it in slope intercept. So I'm going to distribute y minus 3 equals negative 5/4 x plus 5/4 times 8 is plus 10. And then I add 3 to each side. So the equation of a line perpendicular to the line given would be negative 5/4 x plus 13. And that is my equation right there. So this is basically a crash course, how to refresher all on your linear equations, the three different formulas we're going to be using, and parallel and perpendicular lines. What we're about to get into is systems. It's very, very important that you understand this and that this makes sense to you. Let me know if you have any questions and have a wonderful day.